Okay. So in number 6 here, these two functions, they parameterize the same curve. So these have the same image. Let me say that. Now they're different as parametric curves only in that they are different parameterizations. Right? The functions are different. They give you different points for the same time. So you, in some sense, are moving along the parametric curve, same curve, but you're moving along it at different times. So, for example, suppose we have some road, right, going from A to B. Let's make it more literal, from Durham to Chapel Hill, right? And you could drive along that road as a way of describing where that road is. I'm going to show you where the road is by driving on it. And then I could do the same thing, but maybe I'd drive a lot slower. So what's the difference? Well, the difference is, we defined the same path, but we did it in different ways. Namely, I did it slower and you did it faster.
So yeah. You just wanted to do that.
Just words. Yeah, I mean, there's a little bit to show here. I mean, I assert that these are the same, have the same image, but you've got to actually demonstrate that. And here's how you do that. So the image. Well, let's write down f. So f of t is t squared minus 1. That's x and y, and you can persuade yourself without too much trouble that y is equal to x squared minus 1. G of t, now that's a totally different thing. X and y, but if you do the algebra as needed, I claim that, again, y is equal to x squared minus 1. So they trace out the same curve. Right? Now, but are we actually quite sure? Because the next, let's look at number, I don't want to get to that quite yet. But what remains to be shown, clearly both of these parameterize, they're on the same curve, but do they both trace out the whole thing is the question. And yeah, sure they do. I mean, do I know I get to every possible value of x? Yeah, because here it is. I get to some needed value of x at time t. Whatever value of x you want, that's the time t you plug in, and it gets you to that value of x. Ditto here. Is there some time that'll get me to every arbitrary chosen value of x? Yeah, just solve for t. You got to do you're going to have to take a cube root of x plus 1. But cube roots always work. There is no, there's never a case where you can't find a cube root. Yeah. So both of these parameterize the entire parabola, and it's the same parabola, so they parameterize the same curve. And they're different, again, only in the process by which they parameterize.
So 6 and 7 kind of essentially the same question?
They're very similar. Let me get to 7 in just a second. And there is something interesting to say about 7, but yeah. So is everybody okay with 6? Okay, let me stop this and I'll record 7.